When a server or storage system is involved in a cyber incident, the first instinct is often to start investigating immediately. Boot the system. Run repair tools. Rebuild the RAID. Open the files and see what remains. But those actions can permanently change the very data you are trying to investigate or recover. That is why forensic imaging must come before analysis. Every interaction with original media carries risk. Starting an operating system can update logs, timestamps, temporary files, registry entries, and system metadata. A RAID rebuild or synchronization can write new parity information across multiple drives. File system repair tools may remove damaged records, reorganize metadata, or overwrite structures that could still contain recoverable information. Even actions intended to help can make the original condition of the system impossible to recreate. Once that information is overwritten, there may be no way to recover it. Forensic imaging creates a sector-level copy of the source media. Whenever possible, the device is accessed through controlled, read-only methods designed to prevent changes to the original drive. The resulting image captures more than visible files. It can preserve file system metadata, deleted records, unallocated space, partition structures, RAID information, system artifacts, and other data that may be important to both recovery and investigation. The original media is then secured in its received condition. All subsequent work is performed against protected image copies. Working from image copies provides three important advantages. First, it preserves the original evidence. Second, it allows recovery specialists and forensic examiners to test different approaches without placing the source media at additional risk. A RAID configuration can be reconstructed virtually. File system parameters can be adjusted. Repair methods can be evaluated. Data can be exported and validated. If one approach fails or changes the working copy, the analyst can return to the original forensic image and begin again. Third, forensic imaging supports repeatability and defensibility. The acquisition process can be documented, verified with cryptographic hash values, and reviewed by technical teams, legal counsel, insurers, or other authorized parties. One of the most common mistakes after a cyber incident or storage failure is attempting repeated rebuilds before the media has been preserved. Organizations may restart a damaged server, import a foreign RAID configuration, replace drives, run chkdsk, or initiate synchronization in hopes of restoring access quickly. Sometimes those actions work, but when they do not, they can leave the storage environment in a significantly more complicated condition. The safest time to preserve the data is before those changes occur. 1. Preserve. 2. Image. 3. Analyze. 4. Reconstruct. 5. Recover. 6. Validate. At total data migration, our cyber recovery workflow begins with controlled acquisition whenever the condition of the media allows. Original drives are preserved. RAID reconstruction, file system analysis, data recovery, and validation are performed against working image copies within the TDM recovery environment. This protects the source while giving our technical team the flexibility needed to evaluate complex recovery scenarios. When critical systems fail, speed matters. But the first action should not create additional damage. Preserve first. Image second. Analyze third. Because once the original data has been altered, there may be no way to recreate what was there before. Total data migration, cyber recovery. Data recovery. Digital forensics.